Hey guys, welcome to Practical Machine Learning. In this video series, I want to be talking about state-of-the-art machine learning applications, how to implement them in Python or in modern language or these modern frameworks like TensorFlow and Keras. And then but at first I have to, as a tradition, you have to learn the really basics. So for the first few videos are still going to be talking about basics like, linear regression. How a neural network trains itself. What is a gradient? What is the loss of the gradient? And stuff like that. We're not going to get too mathy, but and the exact reason of not getting too mathy is because we want to be really practical. And having too many mathematical notations sometimes will confuse you and you cannot see perhaps the bigger picture. So first of all, let me erase whatever I have wrote on my board. With my, the hell? This is just on my floor. Alright, and I'm going to take off my Luma writer right here. So I want to talk about, first of all, a really intro to machine learning. Why are we using machine learning? Why ML? What are the things that we're doing with ML? Perhaps this goes before that. And then we're going to be talking about how ML, right? How a machine learns. Alright? So first of all, what do we do with machine learning? Probably the hardest thing you can think of is anything that has to do with computer visions. If you look up a machine learning tutorial, it's probably going to be related to a computer visions task. For example, image identification. A lot of them out there, image segmentation, which actually draws the specific bound of an image. Image identification is either just labeling the image and saying whether it's a dog or a cat, or drawing the actual bound of where the cat and the dog exist. Computer visions is the most popular thing, but there are so many things out there. From the really basic, you can predict house prices with machine learning, and in fact, it's actually, although it's really easy to get that thing going, it can be really complex. I think Kaggle has a competition, and it is offered by Zillow, and then whoever can use machine learning to predict the most accurate prices get a really large prize. But from this end of the spectrum is something like house price prediction, and to the other end of the spectrum it might be something like natural language problems. A natural language problem includes stuff like how to translate from speech to text, how to go from Spanish to English, and how to make a machine learn from a series of text that Donald Trump has said, and then later on you can make your machine speak like Donald Trump, stuff like that. So that is what we're doing with ML. And then the question is why we're doing with ML. I think it's bluntly obvious. The reason we're doing those applications with ML is because the machine has the capability of learning a set pattern, and then using that to do stuff. And right, it just you can have an infinite list of why we're doing these applications, right? Why we're doing image identification. It just has too many. The machine can just learn so much that it can replace such a big population of our workforce right now. How to ML. Now this is getting to actual machine learning, right? How do we actually let the machine learn? So I'm not going to say how to ML. Or I think the question how to ML, how to machine learning, is different from how does machine learn. And that probably, and how to machine learning is probably more applicational than how machine learns. So let's talk about how machine learns first. How machine learns is, in really simple phrases, you have a certain set of x and y data set. Let's just keep it for now. And x is only one variable. Like, let's frame this conversation to house price only, right? So y will be the house price, and then x will be the number of rooms, maybe, or number of square inches. I mean square foot. I don't think people use a square inch to measure a house, but square feet then, right? And then it has a certain set of values. And the machine learning, the machine learning model is able to, well, first of all, I gotta provide the machine learning model with a lot of data, right? And the reason is because the machine is going to learn from such a big data set of how these x's map to the y's, that it's going to learn a function of how to map from x to y. And as we can see here, the function is really just y equals to, what is this, 350x, and the machine learning algorithm is going to be able to learn that. So then the question becomes, how does the machine learning algorithm learn that by looking at the data set? And that becomes deeper. I'm going to briefly talk about it in this video, I guess, right now. But that right there, how does it exactly learn this computation from these data set, is the overall image, the overlaying problem of machine learning, right? So that has too big of a conversation to be covered in one video. But a really simple example I can think of is, actually, let's graph these. Um, 700, and this is house price versus, actually the other way around, the number of rooms versus house price. So if we graph the data points, it's just like this, right? And then as humans, we can see a best fit line that I didn't draw perfectly. But as humans, we can draw a best fit line just by looking at it, just by looking at a 2D data set. But the question is, how does a machine know how to do this? And by the way, when a human draws the best fit line, and then if we're given a new x, like 1,500, we're able to tell that the data is about to go right here. And that's the same thing machine learning does, right? After you train such a nice neural network with maybe identifying cats, input a new cat, which is the same thing as here. It basically goes up to a line and says, okay, that is going to be a cat. Now, of course, that is going to be a lot more complicated, but it's basically the same thing. But then the machine learning algorithm is going to, first of all, guess a value. So perhaps at first it's going to guess 0 equals to 0x. And by the way, first of all, we define the function as y equals to theta 1x, where theta 1 is the thing that we're trying to compromise. Well, we're trying to get the value of theta 1. You will be, actually, never mind. So first of all, we want to guess maybe 0. So that is just going to be a line that looks like this, right? And then the way we change, right? And then we can see 0 is a little bit far from 350. So the way we go from 0 to 350 is by defining a loss function. We're going to be calculating how big is the gap between the ideal data point to what we have predicted right now, right? And then we say that if this distance is really large, then we probably want to move the theta 1, current theta 1, by a lot. And the exact value that we move the theta 1, we're going to be discussing in later videos, but we can just say maybe it's going to move by 200 for some reason. 200x. So then, so then after it's 200x, we're going to draw another line. And then we're going to calculate the distance again. And then it's getting smaller, so this time we're going to change by smaller amounts. So we're going to maybe add only 100. So it's going to be 300x. And we're going to change. We're going to define a set number of epochs, or number of times we're going to make this operation, a number of times we're going to change the theta 1. And then after the epochs is done, we're going to get a probably probably satisfying theta 1, and perhaps it's going to be exactly 350. Right, and then at this point the loss is probably the loss is 0. So that is a really basic intro to machine learning. Every single thing kind of stems off from linear regression, really. Right, this is the basis, right, of calculating. Every single machine learning model has, every single one of them has a sort of loss function that you have to define. It can be really simple, but also it might be domain specific. So for the case of images, you might not want to compute the loss from pixel to pixel, right? Because if you just compute a loss from pixel to pixel, then maybe if you have an image that is labeled as a cat, but now you just moved all of the pixels by 1 pixel to the right, then now it's not going to be able to tell that it is a cat. So you have to define perhaps a cleaner or neater loss function, and that loss function is going to be one of the major determinants of how well your machine learning model turns out. So then I guess we can talk about how ML, right? When I learned machine learning, I took Andrew Ng's Stanford machine learning course, and from that course, I implemented basically everything from scratch. So how to implement loss functions, right? Defining a loss function. And what gets really annoying is that when we're doing something called a neural network later on, we have to code out exactly how do we go from one layer to the second layer, and it gets a little bit complicated. We've got to do a lot of vector manipulation. But in real life, you're not going to be using that. You're going to be using really high level machine learning packages. For example, my favorite one is Keras, which has TensorFlow as its backend. Now, so this whole thing, this loss function, whatever thing, might be just, when we're doing, if you want to do with Keras, it might just be one line of code. And that's why if you search on Google, you're going to see tutorials that claims 10 lines of machine learning code that allows you to do image identification. And those work, right? It's so high level that you don't have to worry about the basic mathematical operations. But you still probably want to learn the foundations, because when you have to tune the machine learning model yourself, or you want to get to that pro level, where you want to build out an actual really just state-of-the-art application, just knowing how to use the library is not gonna be all. You have to learn what the basics are and how to tune them correctly. So then maybe one more thing I want to address is, before I'm going to end this video, is how do we go from predicting house prices to something as complex as identifying an image. Now what you do in those cases is you want to have an algorithm that can encapsulate more information than just y equals to theta 1 of x. And that's when stuff like neural networks comes about. And that is when the excitement really begins. So I'll see you guys in the next video, where we'll be talking about perhaps neural networks and how exactly does a neural network work. And then maybe we're going to be implementing the linear regression and maybe neural networks in Python. So hopefully you guys learned a bunch, and have a nice one.